Okay, so skills 2. So the second skills is about research questions and hypotheses. It actually builds upon the constructs that we just did. So to begin with this, research questions is the first thing we have to kind of grapple with, although there's a little bit more to know about hypotheses. A research question, which I think we all have kind of a sense of what that means, more specifically is a question that investigates the relationship between two or more constructs, right? So I could ask, for example, what is the relationship between proficiency and fluency? And if you got our last week's content, you'll go, hey, 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 proficiency is a construct and fluency is a construct. Now, research questions here can be just very bare bones like this. And I would say that as a student in this class, I'm very happy for you to do this first kind, because what interests me is your ability to talk about constructs. However, some of them have more operationalization, aka some of them have more details about how was that construct employed. And in the research, you will probably discover that. So here's another one that has more detail. So for example, are high proficiency learners more fluent than low proficiency learners? L2 learners in this case. So here I've given you more information about the construct proficiency. I've told you that they're L2 learners. I've told you that I'm coding them for high and low, right? I haven't told you what I'm measuring them with, but there's some pretty standard measures for proficiency, so I might not need to do that. Here I haven't done any more information on fluency, for example. Compare this to the next one. So is there an effect for L2 learner proficiency? That's really all I've given you about proficiency in this particular question. On performance on a fluency task requiring simultaneous repetition. So this example, starting with is there, this one is looking at more information on fluency. So it tells you that I'm going to measure it with a task where you are repeating what you hear, let's say in a recording typically, or I guess you could be signing it at a video. As you're sort of receiving it. The idea is as simultaneous as possible. And in theory, this particular measure, it's been done but very infrequently. The idea would be that you would be able to produce more accurately or keep up, let's say, the higher proficiency you were, right? That makes sense. The 101 student is going to have a heck of a time harder simultaneously repeating, signing, speaking, whatever, the message they're getting than someone who's, let's say, an advanced person, someone who's nearing the end of their college level language degree, let's say. So very different kinds of fluencies there, probably. And you're going to guess there's a performance element in that, a proficiency element in that. So, and then if, for example, this last one has more information on both. So I could say, do high proficiency L2 learners of French. So now I'm like, and there's learners of French. Perform better than low proficiency learners on a fluency task requiring simultaneous repetition. So here I've given you a lot of information about both of them. For greater understanding, if you want to pause this and look at more detail, the next two slides, including this one that we're now looking at, have proficiency and fluency coded. So this is slide 3, coded for by color. So this first example on slide 3, proficiency and versions thereof are all in blue, right? If you are not a person who sees color, this matches up to what I described in the previous one, but it's things like proficiency, high proficiency, and effector proficiency, and then high versus low proficiency again. Then on slide 4, I do the same thing with the versions of fluency in red. So the versions from the different questions are like fluency, more fluent than, performance in a fluency task requiring, etc. Okay, so if you have time and want to look at this, you can kind of zoom into where are these constructs being operationalized. So hypotheses, I think we again have sort of a non-technical sense of what this means already. But a hypothesis on one hand is a response to a research question. So because they're related, hypothesis also features two or more constructs. A hypothesis also differs as to how much operationalization it includes, right? So I could do a version for research question 1, such as, what is the relationship between proficiency and fluency? This was the first one that I had that was really vague. And a hypothesis that responds to that goes, I actually could say there is one, or a better hypothesis could be there's a positive correlation between proficiency and fluency, which means, aka when one of them goes up, so does the other. High proficiency, high score, and fluency measure. If you look at the top of this slide 6, you'll see that I've actually asserted that a hypothesis isn't just a response, but it's also a testable prediction. So when you get to the point that you're proposing these, just be aware that they need to be testable, and there has to be some kind of test that makes this possible. And in this moment, we're not going to talk about circularity, right? Circular arguments, but eventually we will get there. But that's the idea. We want something that we can test and say, yes, it's true, no, it's false. So we either accept hypotheses or reject them. Here's another example. This is the last one I proposed back when I was showing you some research questions, the one with the most detail. Do high proficiency L2 learners of French perform better than low proficiency learners on a fluency test requiring simultaneous repetition? And I want you to think for a second, okay, what is a potential hypothesis that is a testable prediction response to this? Okay, this one's mine. Yes. Yes, high proficiency learners will perform better than low proficiency learners on a fluency test requiring simultaneous repetition. AKA, high proficiency will have higher scores on this measure than low proficiency. You know, there's a relationship between the way you frame the research question and the hypothesis. Does X do better? Yes or no, right? And so these are hypotheses. Notice that so far, I've mostly been showing you hypotheses that have to do with sort of improvement, or I have expectations based on these. And we'll see in a little bit that's not always the case. So effect, the word effect, you're going to see a lot, right? It doesn't have to be the word effect, but let's just take the word effect, an effect of something on something else, and kind of use it to get some practice thinking about how hypotheses work. So effect is very general, right? That there's a relationship. So I can ask, what is the effective temperature on? And I could give you lots of things. Let's take temperature as a construct. Next, I'm going to show you some different constructs in sort of a little list and propose to you what kind of effect temperature could have on this other construct, right? So temperature on sleepiness. Sleepiness is going to be my second construct. It's a thing that's measurable in some way. So if I ask you, what is the effective temperature on sleepiness? You could say, well, when it's really cold, I want to stay in bed, so maybe that makes you sleepier. The trick is, in this particular case, it's also true that in, let's say, a hot classroom, if you have a really long class, sometimes people also kind of drift off. So maybe the effective temperature is that the extremes increase sleepiness, something like that, right? So construct A, construct B. A different effective temperature on, let's say, traffic. So traffic, for example, we might expect it on a really cold day. Everybody kind of stays home. You know, maybe it's snowy, maybe it's awful. Although snowy and temperature aren't exactly the same. So there's another variable, another construct, right? Anyway, so you might say when it's cold, everybody stays home. But if it's really warm out, everyone's like, I'm going to the beach or the mountains or whatever it is that we do when it's hot. And so you might say, well, as temperature goes up, so does traffic, right? That's a positive correlation. Or I could ask you, what's the effective temperature on arthritis? If you know anything about arthritis, it's the opposite. When it's really cold, arthritis gives us more pains in our joints. So in that sense, it's, you know, it's the opposite relationship. As temperature goes up, arthritis effects go down. Temperature goes down, arthritis effects go up. That's actually what we call a negative correlation when they're an opposite. I'm not quizzing you on that. I'm just telling you that's what it is. So, you know, the prediction will be something different. And then what about temperature on the rate that coffee cools? Presumably in a cold room, my coffee is going to become cold faster, presumably, right? Et cetera, et cetera, et cetera. So two constructs. Temperature is one, and then really anything else on the other. It depends on what you're studying, of course. Now, in null hypothesis, remember I said that when it came to proficiency, I was proposing that there was going to be some kind of effect, some kind of relationship, that I thought something was going to happen. Well, a null hypothesis, truly the most basic of hypotheses, predicts that there's no effect ever. The motivations for doing that are slightly different in like a stats class than what we're going to do here. So if what I say is slightly different than what your stats teacher says, if you've taken stats, that's okay. But please actually listen to what I'm saying when we get there. So a null hypothesis is the most basic hypothesis. It basically says there's no effect. And I could say there's no relationship, there's no effect, there's no differences, anything like no, right? Null, nothing. There's nothing to see here. So I could say there's no effect of x on y, for example. Or I could say there's no relationship between x and y. Or I could say there's no difference between x and y. Here are some examples of that. There's no effect of temperature on the color of the sky. I don't know if that's true or not, but the null hypothesis is nope, no effect, no relationship. No relationship between temperature and the height of trees. Again, this could be false, but it's a claim, right? It is a hypothesis. I hypothesize no effect, so it's a null hypothesis. Or I could say there's no difference between average temperature in December and average temperature in February, right? Which again could be false, but it is a null hypothesis, no effect, okay? The ability to point out a null hypothesis or to form one based on a couple of constructs is something you need to do for this class, okay? So if you have problems with this concept, make sure you ask me when we have class, okay? All right, so when do you use a null hypothesis? And this is slightly different than what a stats class would say. A null hypothesis is what researchers use when we have no previous study to base expectations on, right? So if I've never studied the effect of temperature on traffic, you know, it's actually less responsible for me to be like, I think this is going to happen, right? Now, it happens to be the case that personal experience dictates. I have some ideas, right? I have some informal testing from life experiences here, right? And so I could logic it out. But if I wanted to say if there's an effect of temperature on traffic on the moon, no, I have no experience with that. I have no idea. So I should say null hypothesis. There's no effect, right? Especially if it's never been studied or nothing similar has been studied. And this is, so we're going to have less personal experience when it comes to like research with capital R, which you're not doing specifically in this class, but just bear with me. Then that's kind of the responsible way to go about that, right? If it's never been done or you can't find any research on it, stick to null hypotheses. Now, regular hypotheses or other hypotheses, I usually call them regular, just so that you're like, it's not null, right? These are ones that we propose based on expectations found in the literature. So let's consider an example about children in school versus children at home, and specifically hours reading, okay? So we have context where the children are they in school, are they in home? And context is a construct in this case, where are we? And then hours reading is some kind of operationalization of another construct, but we'll just pretend it's a construct for now, right? So study 1 might tell me something about how much kids read in school, and studies 2 might tell me something about how much kids read at home. And so I might make a hypothesis about how those are different or similar, right? Based upon the 2 previous studies. Study 1 and study 2 exist in this hypothetical example about how much kids read in those 2 contexts. So it would be irresponsible of me to propose a null hypothesis because research exists. Now, caveat, and this is the biggest thing that's different from something like stats class. It's possible that the previous research suggests that there's no difference, which is going to sound like a null hypothesis. But here's the trick. It isn't. It's only a null hypothesis if you have nothing to base it on. A regular hypothesis can technically say there's no difference. That's completely normal. You can do that. It's really only null, truly, if you don't have anything to base it on. And that's different from a stats class. In stats class, we say there's no difference, and then there is a difference. This one's null, and this one isn't. And in research, that's not how that goes. Sometimes the research does suggest that there's no difference, but because you're basing it on research, it's not null, okay? Essentially, it's like a little mini conclusion, okay? In this case, like I said, there's no null hypothesis because we know something about this. All right, so going on from here, you have the quiz due on Sunday. We'll discuss this on Monday. If you have questions about this content before then, as always, reach out to me, okay?